Hi, I'm Marv. I'm a web developer passionate about all things JavaScript and 3D printing. This is my colleague Mitza.
Hello, I'm Tinta. I'm a Java developer writing different kind of apps, and after so many years, I'm still a curious person, and I hope you are too, because what you will see today will bring huge security improvements to your applications and also a very nice user experience for your end users. So we can get started.
Yeah, let's talk about getting rid of passwords and using web authentication. So just before we dive right into the juicy bits, let's have a look at the agenda. We plan to do a short recap of what authentication is, go through web authentication, a couple of the technologies behind it, explain what web authentication is, go through the ceremonies and understand how they each tie in together for web authentication to work. Talk about platform support, because we want to know where we can use web authentication today. And we'll also have a phishing use case to see the benefits of using web authentication versus classic password-based login. In the end, we're going to share our resources that helped us learn and get to where we are, and hopefully we'll teach you more about web authentication. Now, a short disclaimer, there's a lot of information packed into this presentation, so if you have questions along the way, please drop them in the chat, and as we'll switch between the hot seat, we'll get to answer some of the questions along the way. So let's talk about what authentication is. And I'm sure most of you already know this from the Greek words authentikos, which means true or genuine, and authentes, which means author. Authentication describes the act of validating that the user is who they are. And authentication can be done in many different ways, and we usually tend to group these ways into several categories based on what we use to identify the user. So some of the categories that I'm sure you're familiar with are these on the screen. Something you know are passwords that we use in our day-to-day lives. Probably the majority of our accounts use passwords. Something you have is either a software token or a hardware token, so Google Authenticator, Microsoft Authenticator, and so on, or an RSA Secure ID if we're talking about the physical device. Something you are describes you as a user, so biometrics, your face, your fingerprint, your voice. Somewhere you are is tied to geolocation, with geofencing as an application, maybe let some user log in within a certain radius of a location. And finally, something you do is a more recent one. It's tied to personal patterns, such as the Android line pattern, or maybe if you're familiar with the Windows 8 picture puzzle. And each of them has their strengths and weaknesses, and the industry usually advises us to use a combination of several of them to ensure good security. But nevertheless, there are still many accounts out there that only use passwords. And in a recent study, it's been shown that the average online user has over 90 accounts. And that's a large number, with possible many passwords being reused. Maybe some of them have weak password policies. And at some point, password fatigue might even set in, trying to keep track of all of those passwords and accounts. And you might get, repeat them, which ties into password use. You might say that, okay, I can use a password manager to ensure better password generation and keep them individual. But we've seen that even in the past, the big names have been breached and your credentials have leaked, even if you were using a password manager. Which is not to say that there aren't vulnerabilities on the server side, right? For services that we use to log in, plain text password storage. We've seen emails sent back to us after registering with the password in plain text. We've seen bad use of cryptography, right? Don't invent cryptography, just use whatever is out there and provided by the industry. And what we've seen also on the rise is or are phishing attacks that leave us very vulnerable when using just username and passwords. But today we're going to talk about web authentication. So let's have a look and see how web authentication can help us mitigate some of these risks. I'll leave Mitza to tell us more.
Thank you, Marv. So web authentication, it's actually a specification which enables passwordless authentication by using strong, attested, and scoped public key-based credentials. It was developed by W3C and the Fast Identity Online Alliance. That's a group of big companies trying to create a more secure process around authentication. And you'll hear during these slides new terms like relying party, that's the web application you are building. An authenticator, that's a device or a software that can create and access public key-based credentials. So the browser uses the Web Authentication API, an extension to the Credential Management API. So until today, users had to remember a shared secret, a password, and now with Web Authentication, they have to have access to such a device. And they can come in different forms. They can be either built into your computer or phone, and that's an internal authenticator or a platform authenticator, or they can be external authenticators. Your device will connect to it via different means, via USB, NFC, Bluetooth, and so on. And before going any further, we will clarify a little bit the principle behind web authentication. So we say that there is a strong public key-based credential. And what does it mean? So when you send a message over the channel and you encrypt it with the public key, you get a secure transmission because only the one having the private key can understand the original message. But when you encrypt that message with the private key, anybody can decrypt it and understand the original message. But we still get something out of that. So we have the guarantee of the identity of the sender because only one having the private key can create such a valid message. And this is what's going to be used by web authentication to replace passwords. And there are different ceremonies. The relying party, your application, will have to store the public key-based credentials. So in the registration ceremony, the end user will have to enroll with his device to support web authentication. And in the login ceremony, we will gonna use those public key-based credentials to authenticate after the end user will prove his presence and identity. And of course, we don't want our end users to be locked out of their accounts. We can define different recovery flows. And on top of what the specification has to say about this, we brainstormed a little and came up with a few scenarios of adding more devices to a specific account. So we will now showcase the different flows. This is, let's say, the sign-up page. We removed many fields. We just kept the username for similarity with the sign-up page that you are seeing today with getting a username and registering with a password and so on. So here we will create a new user demo. And in the center of the page, we are seeing a stream of events with logs coming from the server. So here, the relying party, the application, will have to create a challenge and a set of constraints used by the browser to in the communication with the authenticator. So I am creating a new set of public key-based credentials, and I'm going to use this device to create such credentials. And here, the platform authenticator is asking for my confirmation as a natural person to prove my identity to this operating system. And with my fingerprint, I am now creating new credentials for this relying party. And I will store this recovery token safely in my clipboard. And now I will try to log in. So we are using the same username. So now we expect to do the authentication ceremony. Before, with a shared secret, with a password, you usually have one endpoint reading the credentials from the request, the username and the password. You usually hash it and compare it to something you have in the database. And if the output matches whatever you have in the database, then it means that the end user can be authenticated. But with web authentication, the process is split into steps. So the first step is to get an authentication challenge. And now you can see here in the logs that there is a challenge actually. And with this challenge, there is also a hint. So the hint is to use some private key associated with this public key identifier here, and with that to solve the challenge. And I'm proving my presence and identity again. And now the server got back because the authenticator signed the message. The server was able to validate that the authentication is allowed because there was an OK validation with the public key that we already have in the relying party side. And I'm also seeing here that I'm getting back the current username. And I will log out that now actually, and I will leave Marv to show you the next flow. Marv?
Thank you, Mitza. One thing worth mentioning is that these credentials that Mitza told you about, so that private key that was generating during the registration process, is stored according to the specification in a secure hardware module. That module is known on PCs as TPM, Trusted Platform Module, or on Apple devices as the Secure Enclave. And because those credentials never leave that hardware piece, that means that we could lose access to our account if we lose access to the device itself or it gets stolen. So that's why we have a recover account flow, where Mitza helped us store this recovery token in the clipboard. And now we can use it to get back access to our demo account. So if I click here, enter, then you'll see a process very similar to the registration flow, with one important difference in that it won't you won't send the username. You will send a recovery token that is associated with the same username, but for the same endpoint. So we're only using two endpoints in the flows we've described so far. And because this is Mitza's laptop, actually, I can't use his fingerprint. So I'm going to use an external authenticator, which he also mentioned. His fingerprint is tied to the platform capabilities of his laptop, but I don't have access to it. So I'm going to use my YubiKey and hit the USB security key option here. I'm touching the YubiKey to select the profile on it. Then for added measures, security measures, I'm inputting my PIN for this YubiKey and then confirming my presence once again by touching the capacitive button on it. So right now, the recovery account flow is completed. We can see that everything was successful, and I've received a new recovery key should this happen again. And to prove that everything is working, I'll go back to the login page, type in demo, start the flow. This time I'll select my USB security key, select my profile, input my PIN, and then prove my presence once again. And now I'm logged in as demo, and I've recovered access to this account. And the credentials are now stored on this USB key. Now, in the real world, we probably access our account from multiple devices, multiple laptops, multiple phones, you name it. So it might not be enough to be able to recover an account because we want to do that accessing from multiple devices at the same time. So let's go through some options of adding new devices to an existing account. And the specification helps us with an example of how you could do this. And it leverages actually an external authenticator, so a YubiKey, as I have here, which stores the credentials to your account. And you can insert it or connect it to any device, log in to that device, authenticate, and then maybe go through enrolling that device once you're already authenticated on it. Kind of like, hey, attach this device to my account because I've already authenticated on it. Now, this is one example. Maybe not everyone would like to carry a YubiKey. Maybe not everyone would like to spend money on this YubiKey or carry it around. So we thought, how can we improve this this ceremony? We could do something similar to the recovery access token in terms of providing a registration add token that you could move from one device to another. Of course, you authenticate on one, you generate that token, and then you input it in another device. And you could type it, but that's really cumbersome because generally these are rather long random numbers. You could send it over a messaging network or email, but you might not trust those with this sensitive information. So we thought of another step on improving this, and that would be to use WebSockets and connect the two devices via WebSockets through the relying party. So the relying party would provide the WebSocket capability and the room for the two devices to connect, and then they could exchange messages. And we have actually a fourth and final iteration, which leverages WebRTC, so real-time communication, to enable peer-to-peer communication just between the two devices. In the initial step, we connect the two devices to WebSocket room for discovery purposes, that they know that, hey, we want to connect these two devices together. But once they discover each other and connect through WebRTC, then the connection with the relying party is dropped for this type of exchanging of messages. And they can send whatever information they want between them securely, because WebRTC is a secure protocol in this regard. So this is actually the example that we're going to showcase here with the add new device. So I'm in this flow, I'm going to generate the code. And as I mentioned, this is the WebSocket room that Mița is going to connect using his phone. He's logging in right now into an account on his mobile device. And he's going to input this room code. You can see he's already logged in and connected. So after he inputs the code, I receive here a prompt. It says, I understand that this device will be added to Mița's account. And I really have to prove that there's a person behind this intent. We can automate it. The Web Authentication specification tells us that there needs to be user interaction for the process to work. And we've seen many implementations, even Apple devices, that will block you if you don't use a form, for example, in your front-end interactions. So I'm going to tick this box. And once I tick it, I'm sending through WebRTC a message to Mița's device and telling him, hey, I acknowledge, well, in a real scenario, Mița would be me, this laptop, and
Same person.
he would add his laptop to his account. And at that point, when I tick it, I'm receiving the registration add token. You can see it here in the logs. And I'm now ready to enroll this device and going through the USB security key enrollment with the PIN and proving my presence. And I'm now enrolled. And actually, we can see in the final log that the device's endpoint returns 2 devices. If you can spot them, there are 2 user agents now connected to Mița's account. And now, I guess, is a good time, as we pass through the ceremonies, to talk a bit about the phishing use case and see how passwords are vulnerable and web authentication might save our skin.
Yeah, thank you. So yeah, why going through all this trouble of migrating? So there are two situations that we want to explore now. So when we talk about phishing attacks, usually you have the real application, the one with the blue on the right-hand side, and an evil machine intercepting the traffic and acting as the real application. So now the evil machine, the one with the red, it's actually a reverse proxy to the real application. So the end user, if he's tricked into accessing the wrong domain, he will actually use the real application via the evil machine. So if I'm authenticating, that means that I'm exposing my credentials, and someone can log those credentials and then log in as myself in that application. So we have a little setup for this. So this is the login page with the password. And this is actually the evil machine. So I'm redirecting all the traffic from this page towards the evil machine, then accessing the real application. And here is the should be the console of the hacker. And let's see if it's working. So now, after I'll press the login button here, I should be able to see this. Yeah, actually, I think the terminal is broken, so now I'll just open another one. Sorry, and I'll zoom in more. Okay, so now here, if someone is accessing the evil machine, I should be able to see some traffic, and this is the login request. So I'm seeing here the username and the password. So now my credentials are compromised, and well, my password is seen by the hacker person. So we want to see the same situation with the web authentication scenario. So the specification has in place different controls of stopping the authentication attempt when someone is getting tricked into clicking the evil domain. So now, instead of calling that login endpoint with the credentials, actually the first call is to get the challenge from the server. So even if I'm getting the challenge from the server via the evil machine, the real application, besides the challenge, is going to add some metadata to the response. And the evil machine now has two options: either keep the challenge and keep the metadata, everything unchanged. And in this situation, the browser will see that, hey, this user connected to this domain is trying to authenticate on the other domain. So the browser will stop the authentication process with an error message. The relying party ID is not a registrable domain suffix of, or not equal to the current domain, basically stopping the authentication attempt. If the evil machine is going to also change the relying party ID, the metadata, then the browser will still stop the process, because the public key-based credentials are also scoped to a specific domain. So I'm trying to authenticate on authmark.ro. I don't have any credentials on the .cf domain, and the browser will see that there is no way for me to solve this challenge. Then the authentication will stop at the front end side. And we can see this also here. So this is the evil machine. I have this username, user, and now because I previously enrolled with Web Authentication, now I'm sending the authentication request to get the challenge. And I am seeing actually here that request, and I'm seeing only the username. So no sensitive information is exposed, and the authentication was stopped by the browser. So Web Authentication stopped this phishing attack very easily just by comparing the two domains of the evil machine with the one from the user. So as a user, if now I see, hey, actually I'm not on the right domain, even if the certificate, let's say it's correct, but actually there is a 2 letters difference in the domain I'm accessing. So phishing was not possible in this for this application, fortunately. And now, you saw the flows, and we compiled everything in different resources. Myself, because I'm a Java developer and I'm using Spring Boot a lot, I also put everything together in a Spring Boot web authentication starter. And we will see what it means to migrate an existing application to web authentication. So I'll just copy this dependency here, and we will switch to a Spring Boot project. So this would be like a demo application. And here, actually, there is a Spring Data dependency. We have users, very simple users with username and passwords. And those users will have accounts linked to their users. So this is not too complex, but we will have to migrate this application to see what it means for a real application to switch from a password-based authentication method to a passwordless one. And now let's put this dependency in the POM file. Quick nice tip about this library is that by default, if you just put this dependency, you will get some in-memory repositories storing users and credentials. If you're using Spring Data, there is also another flavor with the Web Authentication Spring Boot Starter JPA, creating Spring Data repositories for users and credentials. But this is a short demo, so we will just activate this library now. So enable Web Authentication. This will configure different beans in your application to expose, for example, the Web Authentication repository. So we will also use it here. Authentication repository, and now because I'm using the default one, there is a default Web Authentication user, and this is one option to store users, the default one. So if you don't want to have in-memory users, you can implement the web authentication user interface and maybe link your own modules to the with this interface. So if you are implementing on your own and then you also implement the web authentication user repository, then you don't have to have users in other places, in other repositories. So that was one thing that we did. And the next one would be to add, besides the form login authentication method, a new one, a new authentication method. So, and that's the web authentication configurer we have to activate. And by default, the web authentication configurer will do different things. It will add a filter in your application that's going to expose a few endpoints. So you saw the ceremonies. There are various calls to generate a challenge, to validate that the challenge was signed correctly. Also, there are endpoints for adding new devices. And you don't really care about the inner logic of web authentication when you want to migrate your users. You just wanted to make it work. So now, let's say we want to migrate users. So there are actually two situations when you are creating credentials. Either you have a new user and you have to create a new user and new credentials, or you have an existing user already logged in the application with an existing authentication method, and then you have to link those new credentials to the current user. And for the library to know what to do, we have to provide this user supplier. So with a Lambda here, we should get the current authenticated user. So usually in the security context holder from Spring Security, let me make this bigger. So in the security context holder, we are getting the current user. Okay, so get context and get authentication. Now, this object here may be null. So if I'm accessing an unprotected page or unauthenticated page, then I should not return anything. And the library should know that it needs to create a new user. And you can also deal with this situation. But let's say actually we do have an authenticated user, so someone logged in, and then we have to map from whatever is an authenticated user in your application to something that the library can understand. And what I mean by this is that we will gonna use the web authentication user repository to also store the representation of the user from your application. So web authentication user, maybe the user is already migrated, so there is a chance that I might find a web authentication user there. But if I don't find it, then I should take a decision, either throw an error, maybe we don't want to migrate users, maybe we migrated the users before starting the application. But in our situation, since it's just a demo, we will create the users on the fly. So whenever I want to sign up with web authentication, I'm translating from what it means a user for this application. So instances of my user, these are the principles of my application. I will have to translate them to the web authentication library and just map the username from there. And there are also various fields that you can use. Let's say also the user is enabled. And we will just have to use the repository and save the new instance. This would be the configuration part. So we want to migrate users on the fly. Now, luckily, there are also more things that the library will provide. So besides the Java goodies with the filters, and by the way, the library also supports Spring Webflows. You are also seeing here the version 0.2.1. So I encourage everybody who has the time to take a look and maybe help with this library. So maybe more will add the web authentications to their applications. So there are two additional things. So there are like the Spring Race docs associated with the library. So we get sequence diagrams and so on, a lot of information here. And besides this, you get some agri pages. But with these agri pages, you can try on your local machine, on your dev environment, you can try to do all the flows that you saw in the presentation. So if I'm exposing these files from here, I will be able for this demo application to try to migrate my users. So the first thing that I have to do is to add this folder from the class path with the meta inf resources, web authentication. This is the place. And you saw in the phishing attack that besides the challenge, I also had to provide some metadata. So the relying party ID, do I accept authentication requests coming from a different origin? And here we can configure the application with more properties. And they are just listed in the presentation. The first ones are mandatory. So maybe the endpoints do fit or maybe they don't fit your current application API design, but you can also change them. So when you want to create a new set of credentials, there are two calls involved. Start, getting the challenge, finish, validating the challenge. And the same goes for authentication. We have the session start, to start, getting the challenge, and finish to validate the challenge was okay. And also the other one, the registration add, is to add a new device. So from the currently authenticated user, you may also want to add more devices. So let's see, we added the properties here in the application YAML file. The application will expose itself to the browser as being localhost 8080. We added in the Spring security configuration class the enable annotation, and then we added a web configurer to enable a new web authentication filter in your application to expose those endpoints, and also the dependency. So let's see now if this is working. And I will switch now here to the application. So this is the form login page you are used to. So this comes from Spring Security, is the default page, and then we have some on-the-fly users created when the application starts. So there are like user -0 until 9, and the password is A. So I am able to log in now, and I'm seeing here that there is an account, something with 072 at the end. And this is the current representation of the user. So a user with a password, some roles, and yeah, everything that I think the user details interface from Spring Security is also exposing more fields here. But now I want to migrate. For this user, I want to add web authentication. So here, one of the ugly pages is going to show this button here. So I'm able to register a new set of credentials for the currently authenticated user. And if I'm pressing it, actually I also start on the console. So if I'm pressing it, I'm seeing here the registration start. I'm getting a challenge, some metadata for the browser to scope the credentials to this domain. I'm using this device, and I have to switch to move this pop-up here. It was on the other screen. So I'm asked to prove my presence and identity to Chrome for this domain, localhost. That's the relying party ID. And now the registration finished endpoint was called, and my credentials got saved in the in-memory database. And just for you to be sure, so I am calling the logout page here, and then with user -0, I could log in, but I won't do this. So I am accessing another ugly page, but with this time I'm not asked for a password. I can log in without any password. So I click the button. I have to move again this pop-up here. It's asking me again to prove my presence and identity to this relying party localhost, and then after I'm pressing my fingerprint here, I can authenticate to this application. The same account, the one with 072 at the end, it's being displayed. And I can also see, actually this is a representation of the web authentication user. It has a recovery token. There is an enhancement to the library to not store it as a plain text. Help is more than welcome. And I think this was a fast forward on how to add web authentication to your application. So I will have to switch back to the presentation now. And Marv will tell you more about the next part.
Yep. Thank you, Mitsa. So we've seen how easy it is to actually add web authentication to our Spring Boot application. It's just as easily to add it to your front-end side. As Mitsa showed you, there are some unstyled out-of-the-box components that work with both the Spring Boot starter endpoints, but also they are specification compliant, so you'll be able to use them in every and each of the flows that we've shown thus far. Even a simple version of adding a new device, not the WebRTC one, but the WebRTC components are also there, and you can just import them, use them, configure them to look and behave how you feel and you need. And thanks to the CSS parts specification, you can style each and every piece inside them to look how you need them to look. If we move on to the resources that helped us, we encourage you to take a look at our Tech Web Authn organization on GitHub. You'll find there the application that uses this Spring Boot starter and the web components. You can find the repo for the web components, the Spring Boot starter as well, and the demo application that Mitsa just showed you. But there are other resources that you learn from. So you can check our social media accounts, Medium, learn more about web authentication at webauthentication.guide, where you'll see a deep dive, which unfortunately we didn't have time for in this presentation. A deep dive showcasing the actual code that goes into linking the Credential Manager API to web authentication, and all the things that led us to build the Spring Boot starter and the web components, because handling information in binary form is not easy when communicating over REST, and that's where we come in with the components in the Spring Boot starter. Learn more about the initiative at the FIDO Alliance website, because they're one of the main drivers behind web authentication. You can check out the API on the Mozilla Developer Network, and if you don't have access to a device with web authentication capabilities or an external authenticator, you can definitely use in the latest versions of Chromium browsers the DevTools, which provide the web authentication simulator to generate different kinds of devices and capabilities. Last but not least, let's have a look at platform support and see where we could use web authentication today. So Internet Explorer is just there for reference. We can remove that from our mind, at least. One downside to using platform authentication with platform support on web authentication is desktop Linux. I've mentioned in the beginning that the credentials are stored on the TPM for PCs. Unfortunately, desktop Linux doesn't have proper support for interacting with the TPM. Thus, web authentication does not work with any browser. Another outlier is Firefox, which hasn't been working with macOS, not even in the latest version. So if you want stellar web authentication support, you can check out the external authenticators, which will work everywhere and in each combination that makes sense, obviously, even on Linux. It's been a lot of information in a short time. We've went through a lot of ceremonies and a lot of details, but nothing beats personal experience. So we encourage you to try out web authentication. Just head out to auth.marv.ro. You'll see login, register flow, recovery, and everything. And if you create an account now, you'll be able to also see your users on the screen as they are registered. So I think that's all the time we have left. If there are any questions, this would be a great moment.